On page 3 of your assignment, we're going to spend our time doing some distance problems, distance between points. So on the coordinate grid, I suggest if it's on the coordinate grid, just use Pythagorean theorem. Now I can see I'm going from S at -3 to +4. So I know my horizontal distance is 7. My vertical distance, I'm going from 2 to 5, so that's 3. So we know the hypotenuse squared equals the leg squared plus the leg squared. So in other words, c squared equals 3 squared plus 7 squared. You could just as easily write 7 squared plus 3 squared. So c squared equals 9 plus 49. 9 plus 49 is 58. Take the square root of both sides. The exact answer is the square root of 58. You can write that as the square root of 58, or you can use your calculator. And if we take the square root of 58 on our calculator, you see 7 squared is 49, so it's going to be 7 point something. And we'll say that's about 7.62. Either one is correct. We'll do the same thing for E to F. I'll drop my horizontal line down from E, a vertical line, and then horizontal to F, and then my distance is going to be my hypotenuse. And once again, if I look at my x-coordinate, I'm going from -7 to +3. Notice they're counting by 2's on this one, but it really doesn't matter as long as we look at that coordinates. So from -7 to +3, that's going to be 10. And then I'm going to go from -5 up to 5. That's going to be 10. So I'll go through the same thing again here. I think I'll switch colors just to be on the safe side. So the hypotenuse squared equals leg squared plus leg squared. So c squared equals 10 squared plus 10 squared. Well, that one seems kind of simple. 100 plus 100. C squared is 200. I take the square root. Don't leave it as the square root of 200. That's not simplified. If you think back from Algebra 1, what goes into 200? That would be 2 and 100. I like 100 because the square root of 100 is 10. So my answer is 10 radical 2. Now, could you have just taken your calculator and taken the square root of 200? Of course you could have. Okay. Better go through this on, I got other things opened here. There we go. On decimals, the square root button, square root 200, and we'll say 14.1 or 14.14. Don't give anything beyond that. That's just kind of dumb. 14.1 or 14.14 would be an acceptable answer. Now on question 12 and 14, notice we don't have a grid anymore. Since we don't have a grid, let's use our distance formula. When finding the distance, subtract the x's. They can write. Kind of ruined the song there. Do the same for the y's. Now square both these numbers and take the square root, and then we're done. So on this problem, we're going to subtract our x's. I'm going to say, oh, -5. I always have to think of x1, y1, x2, y2. I always like to think the second one is my second coordinate, but it doesn't really matter. So I'll go -5 minus a -3. We're going to square that. And we'll do the same thing for y. So I'll go 1 minus 8. And I'll square that. -5 plus 3. That'll be -2 squared. 1 minus 8 is -7 squared. When you square a negative, you get a positive, so you get 4 plus 49, which is the square root of 53. That's an exact answer. It doesn't simplify. So if we take the square root of 53 on our calculator, we get about 7.28. So either square root of 53 or 7.28 is the correct answer. Let's do the same thing for 14. I already wrote down the formula in question 12, so I don't think I'll recopy the formula, but I will put I'll use the numbers again. So we'll go 3 minus 5 squared plus 6 minus 1 squared. 3 minus 5 is negative 2. 6 minus 1 is 5. So the square root of negative 2 squared is positive 4. Remember, when you square negative, it's a positive. Plus 25. So the exact answer is the square root of 29. I like the square root of 29. I would just leave it like that. But if you want to write it as a decimal, you certainly can. Take the square root of 29, and it's 5.36. Remember, when you are rounding, if it's more than 5 or more, you round up. If it's less than 5, we round down. Now, if